Hello everyone, my name is Thabiso Mampofu. I am a BTech quality student at Cape Peninsula University of Technology, known as CPUT. The topic I'm going to present today is 4 types of data. Let me first introduce you to the compilers of this work. Firstly, we have Thabiso Mampofu. Secondly, Yonela Anda. Thirdly, Nobathembu Simenu. And the fourth one is Sipesi Ngosikwetana. Now I'm going to show you the outline of the work and the content of the work in the following order. First, we're going to have the introduction to statistics, total quality management, TQM, and data. Secondly, we're going to show population versus sampling. Then we are going to discuss the concept, the main concept, that is 4 types of data. We'll show categorical and numerical data. We'll go deep in discussing the 4 types of data and then give and provide examples. We'll have a comparison table that shows how the types of data differ from each other. Then we will have conclusion. Before we go further, let's first give the background and introduction by defining what is statistics. Statistics is the science that deals with the collection, tabulation, and systematic classification of numerical data. Statistics also help to condense the data and present it in a manner that understandable by everybody. Basically, statistics is a way to convert numbers into useful information so that good decision can be made. Now we are going to show how statistics helps total quality management. According to quality gurus such as W. Edwards Deming, Joseph M. Juran, and others, an uncontrolled variation is the enemy of quality. The PDCA methodology is a continuous loop of planning, doing, checking, or studying and acting. Organizations committed to a continuous improvement culture based on the PDCA cycle depend heavily on data at every step. The PDCA allows analysis, measurement, and identification sources of variation from customers. Let us have a picture of a PDCA cycle and each steps. On the first quadrant, we have the stage that is called planning. This is where things are planned for the new product development or whatever that is being produced. The second stage is the doing stage. It's where the practical work is done. Then when the practical work is done, we collect data. On the third stage, we analyze the collected data and measure it. Then on the fourth stage, we fully implement new ideas or new design informed by the data that we have collected and analyzed. Here's a powerful quote here by Geoffrey Moore. Without a big data analytics, companies are blind and deaf, wandering out onto the web like a deer on a freeway. This shows how important is data in mirroring or in showing how the company is doing well or bad. Data. Let's first discuss what is data. The different values that we can obtain from trying to measure a particular variable is data. A variable is a characteristic of interest. This is the thing that we are interested in. We have 2 types of data, basically, which are ways of collecting data. The first one is primary data. It is the data that we have collected ourselves, but it is expensive and time consuming. Secondly, we have secondary data. It is data that we are borrowing. It is data that is collected by someone else and we borrow that data. There are a number of ways to collect data. Example, observation, surveys, and experiments. However, it is impossible to measure each element in each population. So there are 2 ways. There is population, there is sample. First, population includes all the possible items, units, members of a certain group. Then a sample is a smaller subset or proportion of population that is approximately representative of the larger group. This picture from intelsport.com shows the difference between population and sample. Population, as we have said, includes everything, the entire thing that is in the box, but a sample is a subset, a proportion of what is in the box. So basically what we do, we take a portion and then we count it. Then the portion represents the population. A very important thing is that ethics is very important. We've got to be honest when we are taking a sample and make sure that the sample represents the population. This illustration here shows the types of data. We have two types of data, qualitative and quantitative. Qualitative is also known as categorical data. It has two types, nominal and ordinal. Then quantitative is numerical in nature. It has two types, interval and ratio. But together, these are four types of data. Let's go into details in explaining the two types of data. The qualitative data or categorical data uses textual terms, pictures, videos, or audios. We do not need to convert it into numbers in order to analyze the data. The quantitative data uses numerical values to describe a variable of interest. That is the stuff we're interested in as statistics people. Let's discuss them now into details, the four types of data. First, we have nominal data. The data that is collected can be separated according to discrete categories or labels. Because the categories are counted, the qualitative characteristics become quantitative. Dealing with nominal data, you collect information through frequencies. That is the rate at which something occurs over a period of time or within a data set. You can say it's percentage. To visualize or to show the nominal data, you can use a pie chart or a bar chart. These are the examples of the nominal data. As we have said, it is in categories or labels. Examples are male or female, machine A or B or C. This is how we can categorize a data. These are the examples of nominal data. Here we are shown a proportion or a percentage between male and female. This is only what it can show with the proportion. Secondly, we are only here on the second table, we are shown the rankings, which introduce us to the next type of categorical data, which is ordinal data. Ordinal data has same properties of nominal data with an added feature, namely we rank the data as I've shown in the last picture. The order of values is what's important and significant, but the difference between each one is not really known. However, unlike categorical data, the numbers do have mathematical meaning. For example, you know by rating a service, you can rate it in the following way: 1 very poor, poor, better, good, very good. In a scale of 1 to 5, you are able to see that if you have scored 5, you are doing very good, and if you scored 0 or 1, you are very poor. So that's why we say it gives a meaning. We are coming now to the numerical data. The first type is interval data. It is strictly qualitative data, but interval data does not have a true zero. Interval scales are numeric scales in which you know not only the order but also the exact difference between the values. Example, the difference between 60 and 50 degrees is a measurable 10 degrees. If you minus 60 from 50, you get 10 degrees, as is the difference between 80 and 70 degrees. With interval data, we cannot add and subtract, but cannot multiply or divide. We can add, and however, with interval data, we can add and subtract, but cannot multiply or divide rather. In interval scales are nice because the realm of statistical analysis on these data sets opens up. For example, we can calculate central tendency, mode, median, mean, standard deviation, and others. Here's the problem with interval scales. They don't have what we call a true zero. For example, there's no such thing as no temperature. If you are confused, okay, consider this. If you add 10 degrees plus 10 degrees, it is equal to 20 degrees. No problem with that. 20 degrees is not twice as hot as 10 degrees. However, because there is not such thing as no temperature when it comes to the Celsius scales, we now go to the last one, which is ratio data. It is the king of data types of statistical purpose. This one tells us about the order. They tell us the exact value between units, and they also have an absolute zero. Measuring productivity. These variables can be meaningfully added, subtracted, multiplied, divided. The distinction between ratio and interval is a fine line. If the phrase twice as much can be used to accurately describe the relationship, then the data is ratio. Numerical data continues. The ratio scale provides a wealth of possibilities when it comes to statistical analysis. We can measure central tendency, mode, median, or mean. We can measure the dispersion such as standard deviation, coefficient of variation can also be calculated from ratio scales. Here are the examples of a numerical data. As we can see, it shows how many samples have been taken, what is the average, what is the dispersion, that is the variation, what is the difference between the biggest number and the smallest number. And from here, you are able to have upper control limit and lower control limit, which you can set the standard of quality. You can have, for example, as the table, you can compare the house SOP or the external SOP because you know the control limit from the data samples you have taken and you have analyzed. To show the pattern of variation, we can use C-chart. The C-chart shows the pattern of variation, the going up and down of the quality. It shows you how good or bad you are doing in a company. It kind of gives you a mirror of what is happening inside so that you can know whether we are doing good or we are doing bad. Now, after we have collected the data, we are able to do the following steps. That is the 4 steps of PDCA cycle. To take actions based on what you have discovered on the data analysis. You identify the problems and eliminate the causes. Improve the quality by designing new ways. You plan again, the cycle continues as you see that this is a cycle. Coming to conclusion, here is the table that shows the comparison between the two. Here we have a list of things that can be seen or that can be characteristics of a data. The order of values is known, counts or frequency distribution, mode, median, mean, can quantify the difference between each value, can add or subtract values, can multiply and divide values, has true zero. As you can see, it shows here the ticks, the types of data and the characteristics or the features of it. In conclusion, we have concluded that statistics is an aid in eliminating variation in quality. Management depends on statistics for good decision making. Good decision making comes from converting the data into useful information. Ethics is very important in statistics. Ratio data is the king of data types of statistical purpose. As we come to the end, we say keep calm and use data wisely. Thank you.